Batteries play a critical part in our consumer and business worlds. All too often, we take little notice of how batteries work and how dangerous they can be if not used properly. This program is designed to explain the basics of batteries, how they work, and safety information that you need to know to prevent accidents and injuries when using, handling, storing, or disposing of batteries. When working with batteries, safety is your first concern. Batteries contain sulfuric acid electrolyte. This is a highly corrosive poison. Batteries also produce a mixture of hydrogen and oxygen gases, which will explode if ignited. When working on or near batteries, mixing or pouring acid solutions, always wear protective clothing and protect your eyes and face with safety glasses or goggles and a face shield. Keep all sparks, flames, and cigarettes away. Keep batteries and acid out of the reach of children and untrained employees. If acid contacts skin or eyes, flush the affected areas with clean water for 15 minutes. Then seek prompt medical attention. If acid is taken internally, call medical help immediately. Drink large quantities of water, milk or milk of magnesia, beaten eggs or vegetable oil. Acid spilled on clothing, workbench or floor may be neutralized with baking soda or ammonia solutions. Do not store acid or mix acid solutions in metal containers. Use only glass, ceramic, or acid-resisting plastic vessels. Never discard used containers before they have been rinsed clean, and then puncture them to prevent further use. When charging batteries, keep area well ventilated and keep others away that do not work in battery charging areas. Connect or disconnect batteries only when the charger is switched off. Make sure tools cannot short-circuit battery terminals, and keep vent caps on during charging. Be sure the vent cap holes are not plugged, as the vent caps are designed to let small amounts of gas escape during charging. Refer to your material safety data sheets for additional information about batteries and your safety and health. There are a variety of battery construction and classifications. Batteries are used for many different purposes, so there are many different types of batteries. Refer to your battery manufacturer's instructions for the proper classification for battery use. Here we will discuss only a few of the more common battery classifications. Sealed batteries are those which are constructed with non-renewable vent caps. Sealed batteries are not completely sealed because there will always be a gas exit somewhere in the system. In a sealed battery, no water can be added during service. Service is limited to cleaning and recharging, which must be done to avoid excessive water loss. Another little-known fact is these batteries are closely fitted to the vehicle's correct electrical regulator system and are not generally used as replacement batteries. Non-sealed batteries are constructed with vent caps or removable strips, which allow water to be periodically added to the electrolyte to compensate for water loss. These batteries should be used when an aging voltage control system might cause an increase in the rate of water loss. These are generally good replacement batteries. These batteries are also referred to as flooded battery types. This refers to the water or electrolyte flooding the plates and keeping them covered in this liquid mixture. Top terminal batteries are those designed with the terminals on top of the battery. This provides easy service and maintenance on the terminals. Side terminal batteries are designed to make the battery more compact in certain vehicles. The cable end and connections must be of special design and will not fit onto a top terminal battery. It is not easy to attach jumper cables to side terminal batteries and get adequate current flow into a dead car system. A battery consists of one or more electrochemical cells. Cells are the building blocks of which batteries are constructed. Batteries consist of one or more cells that are electrically connected. In this illustration, you can see a positive electrode that receives electrons from the external circuit when the cell is discharged. A negative electrode donates electrons to the external circuit as the cell discharges. Electrolyte, a mixture of acid and water, provides a mechanism for charge to flow between positive and negative electrodes. A separator electrically isolates the positive and negative electrodes. In some battery designs, the physical distance between the electrodes provides the electrical isolation, and the separator is not needed. The vehicle alternator is the basic source of electrical power for the vehicle system, but it is coupled to the engine, and output depends upon engine speed. The system must be regulated because of the many different engine speeds. The regulator helps avoid excessive voltages or currents, and a battery is used as the secondary power source. The battery maintains a minimum voltage on the system and provides electrical energy whenever the engine is running so slowly that the alternator output is inadequate. Once started, the vehicle will keep running even if the battery is disconnected. However, an essential part of the regulator system would be lost, and lighting intensity would vary enormously. Heaters and air conditioners would work poorly, and system components could suffer damage. The regulator is temperature compensated, and it lowers the maximum voltage applied to the battery as temperature increases. Basically, the alternator or regulator works to maintain proper voltages and currents. The battery supplements the power when the regulator falls below proper operating voltages. You should never attempt to increase the voltage regulator setting as a remedy for an undercharging battery. Batteries perform less well in sub-zero temperatures. Batteries will still provide high currents, but because the internal resistance increases as the temperature decreases, it is the increasing voltage drop which detracts from most battery performance. In cold weather, it is recommended that batteries be checked frequently for proper charging. Batteries are devices that translate chemical energy into electricity. When a battery or cell is inserted into a circuit, it completes a loop, allowing charge to flow uniformly around the circuit. In the external part of the circuit, the charge flow is electrons resulting in electrical current. Within the cell, the charge flows in the form of ions that are transported from one electrode to the other. It is important to remember that the battery system is closed. This means for every electron generated in an oxidation reaction at the negative electrode, there is an electron consumed in the positive. As the process continues, the active materials become depleted and the reactions slow down until the battery is no longer capable of supplying electrons. At this point, the battery is discharged. Reversing the flow of electricity, such as putting current in rather than taking it out, reverses the chemical reactions reversed to restore active material that had been depleted. So it's an electrical and chemical reaction that charges the battery. Most people think that passing a higher charge on a battery than is needed will either speed up the charging or will charge the battery better. Current passed through a battery in excess of the value it can use will do nothing to speed up the recharge and will be wasted in creating heat and in gas generation. Rising battery temperature and vigorous gassing are clear indication of excessive charging currents. If these excessive charging currents are applied for a long period of time, it will reduce the battery life. The best advice is to follow the battery and charger manufacturer's recommendations. Never recharge batteries except in a clean, well-ventilated space. Obviously, keep all sparks, open flames, and smoking or welding away from charging areas. Use only cables and clamps which are well insulated and in good condition to make connections between batteries and chargers. Make connections and disconnects between batteries and the charger when the charger is in the off position, and preferably when the charger main supply cable is withdrawn from the electrical circuit. Keep battery vent caps in position during the recharge sequence. If batteries need water to level the electrolyte, do not add water before starting the recharge. Electrolyte volume expands during recharge, and the excess may flood over the battery covers, causing damage to cables, clamps, racks, and floors. Add water 2 to 3 hours before finishing the recharge. The most important thing is never let the plates get exposed to air. This will corrode and damage the plates. Don't fill the water level up to the filling well to the cap, as this can result in spilling of electrolyte. Again, use only distilled or deionized water for filling batteries. The depth at which a particular object floats in any liquid is governed by the specific gravity of the liquid. This is important to know so the battery's electrolyte may be measured. A battery hydrometer has a glass barrel fitted with a rubber nozzle at one end, which may be dipped into the electrolyte of a battery cell without risking damage to the separators. There's a soft rubber bulb at the other end, which is used to bring electrolyte into the hydrometer. Inside the glass barrel, there's a glass float with graduations on it, so the depth at which it floats can be measured. Always fill and drain the hydrometer 2 to 4 times before pulling out a sample. For automotive batteries, the float should be graduated to cover specific gravities in the range of 1.100 to 1.300. When taking readings, the barrel must be held vertically so the float does not stick to the sides, and it may be necessary to tap the barrel to free the float. After use, the hydrometer should be rinsed with water and carefully stored to avoid damage to the delicate glass float. Be sure and use the battery manufacturer's recommendations to determine proper electrolyte solution mixture by reading the specific gravity readings on the hydrometer. When you test a battery with a hydrometer, you are measuring the amount of sulfuric acid in the electrolyte. If your reading is low, that means the chemistry that makes electrons is lacking. A low reading shows that sulfur is stuck to the battery plates, and when you recharge the battery, the sulfur returns to the electrolyte. Use a baking soda and water mixture to keep the battery clean. Cable connections need to be clean and tightened. Many battery problems are caused by dirty and loose connections. Non-sealed batteries must have the water level checked and use only mineral-free or distilled water. Never use tap water to replenish water in any battery. Don't overfill the battery, particularly in hot weather, because excess electrolytes can be pushed out of the battery, reducing performance. To prevent corrosion on the top post batteries, use a small bead of silicone sealer at the base of the post and place a felt washer over it. Coat the washer with high-temperature grease or Vaseline. Place the cable on the post and tighten, then coat the exposed cable end with the grease. Gases from the battery condensing on metal parts cause most corrosion. Jump-starting a dead battery is an emergency procedure which connects a charged battery into the electrical system of a disabled vehicle to the engine of the stalled vehicle so it may be started. This is a hazardous procedure and must be carried out only by people who know and understand the rules. Of course, we know that many people jump-start cars, and many of them do not have any idea how to perform it safely. Most people do not get hurt when jump-starting vehicles, but many have also been killed or seriously injured because they did not know how to jump-start safely. Remember that batteries can explode and throw corrosive sulfuric acid on anyone standing nearby. If you are working at night or in dark conditions, never use a match or open flames to provide light. Never smoke when jump-starting a vehicle, and don't allow tools near the batteries, as they can create sparks if they touch the battery terminals or connections. The procedure is simple if you follow them all. Many people just connect the cables and then turn the ignition. That's the dangerous method of jump-starting. First of all, vehicle and battery manufacturers know best how to safely jump-start, so follow their instructions. Make sure you know how a vehicle is grounded. Some vehicles are negative grounded and some are positive grounded. Make sure you wear proper protection for your hands, skin, face, and eyes. Remove all jewelry. No open flames, sparks, or smoking. Don't attempt to jump-start a vehicle if gasoline fumes are present around either the good battery vehicle or the dead battery vehicle. Check the dead vehicle's battery for proper water level. Fill as needed. Use extreme caution with jumper cables. Avoid connecting the cables in reverse polarity. Place the good battery vehicle close enough to the dead battery vehicle so the jumper cables reach without stretching. Do not allow either vehicle to touch each other. Turn the good battery vehicle off before making any jumper cable connections between the two batteries. Clean the battery terminal surfaces of corrosion to ensure a clean and quick connection. Turn off all unnecessary electrical switches, such as radios and other electrical loads. Okay, now the 6 steps to a successful and safe jump start. 1. Connect one end of the positive jumper cable to the positive post of the dead battery. 2. Connect the other end of the positive cable to the positive post of the good battery. 3. Connect one end of the negative cable to the negative post of the good battery. 4. Connect the other end of the negative jumper cable to the engine block of the dead vehicle. Notice we didn't say connect the negative jumper cable to the negative battery post. Connecting to the engine block reduces the chance of creating a spark near the dead battery, which could cause an explosion. The last connection is to the dead vehicle's engine block. With the vehicle securely parked and the transmission in park or neutral and the handbrake set, start the good battery vehicle's engine and increase the engine speed, and wait about 2 to 5 minutes for the dead battery to charge. Start the dead battery vehicle. After the vehicle is started and running, remove all the cables in reverse order, beginning with the engine block negative cable. Watch your hands to make sure they don't catch the rotating fan or belts. Again, it's important to know how your vehicle is grounded and to follow the vehicle and battery manufacturer's instructions, as they may be different than the information we have provided. Of particular importance is battery storage and maintenance. This refers to businesses that stock batteries and includes all types of batteries, whether they are wet, dry charged, moist and charged, or low water loss construction. Equipment and tools should include a slow charger, a fast charger, battery connectors, hydrometers, and thermometers. Other items that should be available are a carrying strap, terminal cleaner, water filler, and a supply of baking soda for neutralizing acid. The battery room should be equipped with a good exhaust fan for ventilation. Safety equipment such as eye and face protection, rubber gloves, safety shoes, and acid-proof clothing should be provided. All batteries should be stored in a cool, dry place in an upright position. Batteries should be rotated on a strict first-in, first-out basis. One of the major causes of problems with replacement batteries is failure to follow the first-in, first-out procedure. Batteries should never be piled on top of one another, and they should be stored in racks or durable wooden shelves. Never store batteries on concrete. Be sure to check new batteries before placing them in stock to make sure they are fully charged and that the electrolyte is up to the indicator level in all cells. Storing batteries for an extended period of time may result in reduced performance and service life. The best advice is to make sure everyone working with batteries is properly trained and that the battery manufacturer's instructions are followed. When batteries are declared dead and unserviceable, never dump batteries or discard them in regular trash. Batteries can be recycled, but more importantly, they are hazardous materials and must be properly disposed. You have all seen dead batteries dumped in a pile. Some are tipped over or upside down. This is extremely hazardous for several reasons. Electrolyte contains sulfuric acid, which can soak into the ground, creating hazardous conditions and leaking into groundwater. Without proper stacking of batteries, they can create physical hazards for anyone trying to move them. Potential fire and explosion hazards can be created by improper storage. Follow your company's policies and procedures for storing and disposing of unserviceable batteries. Certainly, there is much more information about batteries, maintenance, and safety rules. Always follow the battery and vehicle manufacturer's instructions. Learn more about batteries and read and follow the information printed on material safety data sheets, often called MSDSs. Take the time to work and act safely. Follow the rules. And of course, realize that batteries are hazardous materials and can harm you and your health if not used properly. Thank you.